Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the chain rule in computing the derivative of this given composite function. This time, our function is actually an example of nested compositions because we have here f of x being equal to sine to the power of 5 and the angle is expressed as 2x plus 3. Take note that if we have the exponent here, of course we can move it out. This is also same as writing this into this form, sine of the angle 2x plus 3 and raised to the power of 5. They're just the same as we have the exponent here or there. Now, I'm talking about the nested because when you look into this form, supposedly we could have an expression where we have the exponent and we tend to have this g of x here. However, take note that whatever inside here, it also has another function for the angle. This would mean if our f of x is expressed as h of g of x, or in this case h of g of x, we can say that h of x is x to the power of 5 and our g of x is just equal to the sine of 2x plus 3, as we can substitute that here to get this entire expression, and that is true. However, when you look at our g of x is also another composition or composite functions, because this can be written like, say for example, g of x is also a composition of, let's say, k of m of x, or in other form k of m of x, where our k of x is the sine x, but this angle this time is your m of x being 2x plus 3. As you substitute that here, you will get g of x, and that is again, as you substitute that here, you will get this intended original function. So what is my point of sharing this? Knowing that our function here has nested compositions, we are going to apply here the chain rule twice. Yes, you heard it right, twice. We're going to solve for of course we know that the first derivative is for the composition according to chain rule is in this manner. Okay, the derivative of whatever this entire function is, treating this as 1 using the power law, times the derivative of whatever is inside. However, since the function inside is also a composition, so this would mean this g prime of x could also be solved using the composition of k of x and g of x. And here this g prime of x should be the result when you have k prime of m of x times the derivative of m of x. In short, we're going to start with this. As soon as we solve for g of prime of x, we use that here to solve for the intended derivative. Yes, this is why we're doing the derivative or the chain rule twice. So please hear me out as I try to solve for this using this quantity. Of course, let's try first k of m of x. Do we know, as identified already as the composition of here, this would mean this is just sine of 2x plus 3. In short, this is equal to g of x indicated here and here. Okay, so that's our g of x itself. Let me erase this. So to solve for the derivative of g, which is a combination of this, let's solve first the k prime of m of x. So derive that first. Of course, as you take this entirely, okay, you take that entirely, your derivative for that is actually the derivative of sine x, which is positive cosine of 2x plus 3. This is the derivative of k of m of x. But take note, in our formula here, we need m prime of x. So our m of x is already identified here as 2x plus 3. So in short, m of x is the angle the combination of k and m is this function here inside, and of course later on f of x will include the exponent of 5. So your m prime of x, using the rule for sum and then a constant multiple, you have 2x1 minus 1 plus the derivative of a constant 3 is 0. This is 2 times x to the power of 0, or just equal to 2, because that's just equal to 1. Now that we have completed this, we now have g prime of x, which is the product of the two. This k prime of m of x, you will have here cosine of 2x plus 3, and let me enclose this as a grouping symbol, times 2, okay, which would mean g prime of x is 2 cosine of the angle 2x plus 3. This is just g prime. You're already using here the chain rule, but this is just a composition of another chain rule which involves the larger value of the function. But since this is g of x already identified as this, so don't need to solve for that, what we need to do here is just the derivative of h of g of x, which is the derivative of this original function here. So we are going to use here the power law, or the rule for differentiating power, as this is the exponent, treating this as 1. So let me have it here. Let me write it first here, right? So I'll be guided. F of x is actually sine of 2x plus 3 raised to the power of 5. Again, understandably, there's a 5 there. We just simply move it out. So what will happen here for f prime of x is specifically just for this composition h prime of g of x. So we're going to use here the power law. Okay, power law. So you have here 5 times this as 1. Okay, so you have here sine of 2x plus 3. Let me make this as a bracket, raised to the power of 5 minus 1, because we have here n, according to the rule of power, minus 1. Hence, this is just 5 sine 2x plus 3 raised to the power of 4. If I would like to return that here, you could also rewrite this as 5 sine to the power of 4 of the angle 2x plus 3. So this is just this portion here. And since we already have this, we can now determine the final result for the derivative of the entire function. We have h prime g of x times g prime of x, where this is again another chain rule. We're already done with that. So the final answer here is 5 sine to the power of 4 of angle 2x plus 3 times, you will have this, 2 cosine of the angle 2x plus 3. So multiplying 2 and 5, you will get here 10 sine to the power of 4 of 2x plus 3, and then you have your cosine of 2x plus 3. You can no longer combine these two because they are of different trigonometric functions, and hence this is the result now of our given function. Take note that what we did here is the possibility of nested compositions. So again, the point here is this: we have here a composition of a power, but when you look at the function inside, the angle is also not x. So we have another composition there. So please review this, because this similar item might also come out in your future preparations. Thank you very much for watching. So what are you waiting for? Subscribe now.